guys, what we hopefully talked about. So, quick review. When you correct capacitor, guys, there are two ways of correcting capacitors. You can either add motors, synchronous motors, right? Or capacitors. Karen, there are two also locations for the capacitors. There one location is called the poor man's way. You locate the correction will be the best way is correct at the level of the offender. The offenders, guys, are the motors. So if you correct right at the level of the offender, which is method number one, local, it's called local correction, best and more expensive. So you go to every single motor, and next to every single motor, you put a capacitor bank. I don't know if you guys have seen it when we went to Allianz. There was a bank of capacitors right at the top of the motor control center. So right next to every capacitor, you tie a capacitor, every motor a capacitor connected. Typically 15 horsepower or more, you tie that one. That's method number one. And method number two, which is the cheaper, you go right at the switchgear, guys. See where the switchgear is? Right at the switchgear, the main panel, and you tie a capacitor bank there. You correct if your power factor is 90% or less. Can I get you guys to understand? First, we correct if the power factor is 90% or less. There are two ways of correcting. Either you correct at the level of the offender, 15 horsepower induction motor or more, you stick a capacitor right or more, every motor a capacitor, or you go right at the switchgear. We have it here done with it, the cheap way. We right at the switchgear and you tie a bank of capacitors and you tie them to our switchgear. And that will take care of your motor. When do you correct? If your power factor is 90. Why do you correct? Because you get penalized. Why do you get penalized by Excel? Because if you guys see the current went down, right? If you don't correct it, then you're pulling more current than what you're paying for. Okay, having said this one, let's go look at this example, gentlemen. Here's my example number one. I'm using method number two, the cheap way, which is I have a switchgear here, and I'm going to correct the power factor. Here's the information on the switchgear. The switchgear, guys, the power factor is 80%. It's pulling 1,000 amp, and the voltage is 480, and it's three-phase. Can you see that? This is the information about the switchgear. And I'm asking Adam to go correct this power factor to 97% power factor. Did you guys hear me? I have a power system following. I measure the power factor is 80%. I measure the current 1,000. I measure the voltage 480. It's three-phase system. I need to correct the power factor from 80 to 97%. First, then I need to tie a bit by the capacitor bank and bring a conductor and a fuse and a disconnect and tie it to the system, like you guys always do. Did you guys hear what I'm doing? First, we size the capacitor, like we size transformers. Then when you tie that transformer, or the capacitor in this case, into the system, right at the panel. That's the cheaper way. Everybody understand what we're doing? Can I have thumbs up, Chad? So the first thing we need to do is size the capacitor. Second, size the conductor. Third, size the overconduction device. Fourth, size the disconnect. Let's go ahead and do it. Okay, the first thing, we talked about the kVAR, guys. Here's the kVA. The power triangle right here. The method that you use, guys, to do the calculation here is right in here. Here's the formula. You need to find the true power. The true power, in order to size, you need to find the true power. The true power is 1.73. You guys have see the formula? Times voltage, times current, times power factor existing, times 480, times the current is 1,000, times the power factor existence. Adam, can I emphasize the word existence power factor here? Not the new one. And when you do that, your 664 kW is your true power factor. Who cares? Why did I do the true power factor? In order to do the correction factor, the easier way, guys, you have to find the true power factor, the true power. This is the formula for finding the true power. And we've done, you guys have done that. You should have done that with us a couple of times too. Okay, now I would like you guys to go to the table that we were just looking at, please. Electrical Wire and Industrial, page 193, table 11-1, or DeWalt, also 1-12. If you guys go from 80% power factor to 97% power factor, you're going to find a multiplier, Adam. The multiplier, step number 2, is called M equal, that's my multiplier, 0.499. Who cares? That's the multiplier that's going to decide the size of the capacitor. One more time. Step number 1, you need to find the true power. Easy. Here's the formula. Step number 2, based on 80% power factor, original, and a corrected 97. Remember how I was circling these guys? A power factor, go to the table. It will give you the multiplier is 0.499. Please verify that you know how to use this table. Derek, the first number here is the first column. And the second number, 97, is the first row. Any comments, guys? Any questions about finding the M? Step number 1, we found the 2 power. Step number 2, we find the M. Does it make sense? Karen? Yes? No? Finding the M and finding the true power?
So, is it the DeWalt on 193 that's it?
DeWalt is 1-12. The problem with DeWalt, guys, it doesn't have the whole big picture. It doesn't have the whole, the big sheet. Okay? I think we still have it here. If I didn't, I don't think did I close it? Ouch, I closed them. Okay. So, it takes a second here to load them. Yeah, I think it was somewhere here. Okay, so if you guys look at that table here, what was the original was 80. We need an original power factor of 80 right here. Do you see it, Adam? Right at the bottom. Here's my 80. My original power factor was 80, and I need to correct to what? To 97. So I don't know how we're gonna go all the way to 97. Here's 97, and mine was my correction 0.449. 0.449. Can you guys see that? Where did it go? Always 97. 0.449. There you go, right here. This is the number. Can you guys see that? Oh, 0.449. That's the number that looks from this table. On the test, guys, we'll be using this table to find it. Okay? I can't emphasize the original power factor. Here's the 97. Here's the corrected. The original is right in here. 80. Can you guys see that? So I can't get all of them in the same. It's too big. Okay, so make sure you know how to use this table before we go ahead and start. So, all right, so let's go ahead and we know how to use this table, hopefully. So, any question, guys, about them? Straightforward from the table. The only thing you need to know is just how to use it. Step number 3, Adam. Step number 3 is you need to multiply the M by the true power. So, which is piece of cake? 0.499. Multiply that baby by 664 kW. When you do the math on that one, you should end up with a 331 kVAR. That's the kVAR that you need. That's the kVAR that you need. That's your kVAR that you need. Any comments, guys? Any questions? Straightforward. See how simple the math is? Very simple. Now, step number 4, you need to take 331 kVAR, the value, take it to electrical wiring industrial, page 196, Adam, in the table 11-3, and go to the next standard. The next standard, gentlemen, will get you 400. The next standard will get you 400. Derek, did you find it in that table? Did you find 400 in the table?
Yeah, you saying you want to go down to...
Up. You're going to find it up on the first column. Okay, now if it's not on the table, now if you table 11-3, 11-3, the first column stops at 125, right? Derek, see that? At 125. Then after that, for the sake of the test, guys, start using multiples of 100. So I have 331 kVA, the next standard 400. For the sake of the exercise. In real life, you're going to go to the manufacturer and find what the manufacturer provide and take the next standard. So the table really doesn't give you as high. The table that we have, guys, doesn't go that high. So on the test, I'm going to be telling you guys, when you reach this value, go to the next standard, which is 100, the next 100. 331, next 100 is 400. Cool? Okay, so then, but you should start with this table though. All right, so now let's go to, the next is piece of cake, guys. Now we need to go size the, we found the size of the capacitor. Now you can go and take your 400 k bar, these are bars, divide them by 1.73, 480, and you're going to get yourself a 482 amps. Then you're going to take a 1.35 multiplier times 482. That's the size of the capacitor feeder. That will give you 651 amp. And then here you take the 651 amps divided by 2. That will get you 326 amps. Take them to 3 to the 16, guys. And you're going to end up with two sets, and 3 conductors. No, not 4. And 400 kcm THHN. Now, where did that magic number came to be? Where would that magic number came to be is 460.88. That's where this number guys come to be. Any comments, any questions? The code, there's a Article 460 guys talk about capacitors. It tells you, hey, if you have a capacitor and you size a conductor, don't choose 1.25, use 1.35. And supposedly it's because the capacitor guys charge and discharge, so they abuse the conductors more, so we up them more than 125. This is how it looks like, guys. Capacitor 1, 2, 3 tied together from one end and bringing phase A, phase B, phase C to them. Any comments, guys? Any questions about sizing? See how easy that? Just one multiplier. Any comments, guys? Any questions about that? Comments, questions? That's how you size the conductor. So let's go size. Okay. After that, we're going to size two more things. That's done. We're going to size the disconnect and the overcapacity device. Cool. Next, disconnect. So we got the conductors, my friends. Next one, we need to size overcapacity device. I use the same thing, 1.35. Multiply it by the same number, guys. 482 gets you the same number, 651 amp. And this is CSK. This is from Chad, basically. Interpretation of Article 460.8b. And CSK is my initial, of course. Then you take the 651 amp, take it down to the next standard, which is 600. So Derek, when you size the fuse, the code says as low as practical. So how are you going to measure that? As low as practical. That's what this Article 460.8b. How are you going to do that? So my interpretation, put my initials here, so disclaimer. Use the same multiplier like a disconnect and size it down. Cool? That 135 is, you guys, everything is 135. There is no change with it. Any comments, guys? Have any questions about that? See how easy that is? Derek, you good? Okay. Now let's go to the disconnect. Can anybody guess what the multiplier for the disconnect would be? Anybody? The disconnect would be what? 135. Same thing. Same thing. 135, 1.35 times 482 equal the same number, 651 amp. This is, guys, coming, the same thing, this multiplier is coming from Article 460.8c this time. And then, my friends, when you take the 651 amp, take it to DeWalt 3-12, and that will get you, for disconnects, a healthy 800 amp. Go up if it's not standard, and that will get you a healthy 800 amp. Done. You can see how easy that is. 135. All what you have to do, find the amps, and the rest is piece of cake. Any comments, any questions, my friends? Any comments, any questions? The calculation really is so easy, but you need to know how to use the tables though. Let me know when I move to the next example. Cool? Karen, everybody's good? Yes, no? Okay. Next example, same calculation. I have, except this time, Derek, I have 75% power factor. The amp is 4,000. The voltage is 480. And I need to correct to a 97% power factor. Did you guys see that? And I need to calculate the same thing. Can I have thumbs up, Chad? We're repeating ourselves here. All right, let's go do the same calculation. Here's the calculation, guys, that we're going to do. We got them here. Here's the formula. Write it down. So 1.73, you're going to multiply this baby by 480. You're going to multiply it this time by 4,000. And don't forget to multiply it by 0.75, the original power factor. You're going to end up with 2491 kW. That's your true power. Step number one, we find the true power. From 75 atom percent all the way to 97% power factor, original corrected, using the table from electrical, wiring, industrial, table, page 194, table 11, we just there. My M, gentlemen and ladies and gentlemen, is 0.631. That's my M. Everybody knows how to find the M? Straightforward. You're going to go between 75 and 90, go to the M, and that will be your M. What's M? Multiplier. No gimmicks, nothing. So found my M. Any comments, guys? Any questions about the M? Matt, does it make sense? Found the M from the table. Can I move? No? Wait. Is it the same number, Derek? See you crunching your numbers. Okay. Then, step number 3, guys, is to find the kVAR of the capacitors. Exactly like we've done before. So, we got my point. So, I have my multiplier, which is M. Here's the formula. 0.631. Multiply that baby by 2491 kW. And that will get you a 152, oops, 1572. 1572 kVAR. Then step number 4, you need to take it to, you need to take the 1572 to this table. Obviously, this table way out of whack because it doesn't have it, and then it will go to the next standard, which is 1600 kVAR. I don't know if it's doable or not, but that's what you get. So 1600 kVAR. Next 100. You go to the next 100. Does it make sense? Karen, if you go to the table 11-3, it stops at 125. So after 125, what do we do? Please go to the next 100 for the practical application anyway. Okay. Cool. All right, so now we found the size. Now the next is, guys, straightforward. After you find your size, it becomes 1600 kVAR divided by 1.73 times 480. You do your math, that will give you 1927 amps. Multiplied by 1.3 to size the feeder. 192 27. 1927. When you do your math, it's 2601 amp. And again, you take the 2601 amp, divide it. I'm going to parallel 10 sets, if you guys have done that with me. 260.1 amp. When you do your math on this, it gives you 10 sets of 3 conductors. Each conductor is 300 kcm THHM. And I'm going fast because you guys know how to pedal. I have 2,601 amps. How are you going to carry them? I'm going to run 10 sets to that bank. It's a lot of conductors. Any comments, guys? Any questions? Straightforward. Okay. Yes, no, move, Chad. Good. Okay. Overcome detection device. Adam, the same thing. 1.35. So repeat yourself basically. 1927 equal 2601 amp. Take yourself to 2601 amp. Take it to 240.6, gentlemen. That'll get you 2500 amp. You go down to your 2500 amp. So your overcome detection device is 2500 amp. Shall we do the disconnect? Disconnect, same way. You guys, same calculation. The disconnect, my friends, is now we're moving 1.35, the same calculation. 1927 equal 2601 amp. Take this baby, 2601 amp, take it to the volt 3-12, and that will get you 3000 amp disconnect. 3000 amp disconnect. Cool? That's my next disconnect. Now these two examples, Karen, is correcting at the level of the main panel. The next two examples, guys, will be correct right at the offender level, right at the level of the induction motor, which is even easier. Did you guys hear me? Correcting at the level of the switch gear, you have to do more math. Correcting at the level of the capacitor, there are tables, you pull the information directly from the tables. Can I move to the second two examples, guys? Cool? Yes? No? So you can see that they're repeating each other. Okay, here's the second set of two examples, guys. This one is for right at the level of the, can you guys see, here's a motor. Right at the motor, 350 horsepower, 480, three-phase, U-frame motor, U-frame, you need the frame. I need to tie a capacitor right to the motor and size, number 1, find the capacitor, number 2, the conductor, number 3, the fuse, number 4, the disconnect. Given the following, correction from 94 all the percent all the way to 97, power factor, electrical wiring industrial, page 194, table 11.2. That's the information that we'll be pulling from. Can you guys see that? You have all this info, right? Everybody got the info in front of them, what we're doing? All right, let's go do it. Okay, now, Derek, you can go take 350 horsepower at 480, U-frame, RPM, 1800 RPM. Do you guys remember we just talked about this one? If you go there, you're going to find from that table directly 60 kVAR. Right from the get-go, 60 kVAR. Everybody knows how to use this table, guys? Make sure you go to table 11-2, go to U-frame, go to 800 RPM, it's 480, piece of cake. No gimmicks, nothing. 60 kVAR. Cool. Next. So now you're going to find the full load current. Take the 60 kVAR, the capacitor that you bought, 1.73 times 480. And if you guys do the math on this, 72 amps. And then you're going to take the same 1.35, same multiplication, guys. 72. Now we're repeating ourselves. That'll get you 97 amps. Okay, and you take the 97 amps and go size yourself a conductor from this table. That will get you 3 conductors, number 3AWGTHHN. Done. And where does the And everybody knows where this number guys came to be, right? This is from 460 dot, where are we here? 88. These are same multiplier like we did before. Derek, does it make sense? So that's a capacitor feeder, gentlemen. What do you guys guess the overconduction device and the disconnect would be? Same multiplication. Cool? You guys are fast writers. My God, I turn around and you're done. Am I the slowest kid here or what? Okay, overconduction device, same multiplication, gentlemen. You take the 1.35, multiply this really by 72. We already did that, so it's 97 amps. Except you're going to take the 97 amps, take them 240.6, and that'll get you 90 amp. Go down, please. 90 amp. We talked about this. Where does this coming from? This multiplier is coming from 460.8B. And also your friend CSK, Chad. That's a little opinion. Okay, the capacitor disconnect, guys, I'm going to do it right away. The 1.35, same thing, multiplied by 92, same calculation, 97 amps. Then you take the 97 amps, take it to 240. Oops, no, this is going to be to a different table. This is, we're taking it to DeWalt 3-12, 3-12. When you go there, you end up with 100 amp disconnect. You go up. And where did that number come from? One more time, I'm not going to write it again. This is coming from 460.8C. NEC. Last example, gentlemen. Last example. Any comments? See why I wanted to do it, guys, with the capacitor? Not a whole lot of knowledge, really. 1.35, that's all. Knowing how to use the table is all what it's all about. Last example. Any comments, any questions before I switch into the last example? Derek, good? All right. Last example. Here's the problem with this guy. There's a problem with this guy. I am correcting at the offender level, at the motor level, example number 4. The voltage system is 208 though. The voltage system is 208. That triggers something. That T-frame, it's a T-frame, not U-frame. They're two different type of frames that they build the motors on. 1800 RPM, I need to do the same thing. So keep in mind, it's a 208 system, not 480. So you have to do one little thing. Okay, gentlemen. You take the same thing, you're going to take the 200 horsepower at 208 volt, at T-frame, 1800 RPM, same table. And if you do that, you're going to find, when we did that one, okay, so we got the two frame, Chad. We got ourselves, when you guys go there, you're going to find when you go to this, you're going to find 50 kVAR. Here's your 50 kVAR. Now, there's one little problem, Karen. That 50 kVAR is meant for 480 system, Derek. 480 system. But what's my system? 208. Can you guys see that little note at the bottom of the table? What does that note tells you? It tells you, hey, by the way, if you're using 208 voltage system, if you're using a 208 voltage system, don't sweat it too hard. Just go 1.33, multiply 1.33 with whatever you came up with, the 50 kVAR, and that up it, that'll get you 67 kVAR. Okay? So just up it 33%. Everybody understand why that? Because there's a note, Derek, right under the table. It says, hey, if you're using this, go 33% extra. Then you take the 67 kVAR, take it to electrical and industrial table 11-3, 196, the next table, and that, gentleman, will get you a 70 kVAR. So amps, we went from a 50 to a 70 because the voltage is 208, not 480. Does it match what you have there?
So we go to 240 for that?
Yep. You don't even have to go to any column. Just go to the first column. Go right through the first column and find the size. Yep, next size up. The first column. Gentlemen, after you do this, you're done. The only tricky thing, guys, on this one is really this method here. That's that tricky one. Compensate for the lower voltage. Next, any questions about this? So when I give you on the test, guys, what voltage, please pay attention to the voltage. I typically give you 480 or 208. The rest is history, gentlemen. And after you do that math, you take your 70 ampere, 70k bar divided by 1.73 times 208 this time. Remember, it's a 2-8er. That'll give you 195 amps. Then you multiply 1.35 times 195. That'll get you a healthy 263 amps. After, then you take the 263 amps, take it to the notoriously famous table, 310.15 B16, 75-degree column, and that will get you 3 conductors, gentlemen. Number 300 KCM THHN. Done. Any comments, guys? Any questions? So that's the size of the conductor, straightforward. Shall we go to the overcome protection device, gentlemen? When you're ready. You're probably done with your homework, huh? While I'm doing it. Okay. Capacitor overcome protection device, guys, one piece of cake, 1.35 times 194. That'll get you 264 amps. 264 amps. Take this one to 240.6, and that'll get you, go down to 250, please. If it's not a standard 250 amp fuse.
195 instead of 194.
194. Is it 94, 95?
95.
Why did I put 94? Did I steal? Did somebody steal one? There you go. Thank you. 1.35 times 194. Okay, I just read it. Okay, so that's good. Thank you. And then the same thing here. 1.35 times. Did I do it before 1.35 or what? Yeah, I did it. I don't know why I lowered the number. 195. You never know what comes from Mr. Curdy here. Okay, then 264 amp. Take it to the watt this time, PW. And that would be 3-12, gentlemen. That gets you a 400 amp. You go up. That's it. So that's 4 examples about capacitors, plus a lecture. Hopefully, guys, it sticks. That's how you correct capacitors based on the offenders, the motor, as well as based on the system. Okay. Homework number 9. The system is 600 volt, guys, 3-phase, 1200 amps, 70%. Correct to a 95% power factor. Homework number 10, 208 3-phase, 25 horsepower, T-frame, 600 RPM, correct power factor to 94 to 97. For motors, they give you a range. Shall we? If you guys want to do it right away and give it to me, that's great, while it's hot in your brain. Otherwise, that will be your homework for these two. Straightforward, one from what we have done. Any comments, gentlemen, any questions? Comments, questions? You can see where I tied the two together. They are directly related, the calculation. Any comments, any questions? What I hope, Matt, is we will print all the lighting today and hit the power. So I know you guys lost 3 days now. Don't sweat it too hard. We have time at the end, though. but I want you to keep going, please. Don't panic. Don't. We have time, but just keep kicking. I want the lighting done though. Cool. Any question for your friend Chad? Did they harass you guys on a Wednesday, on a Thursday? A little bit. All right. Thank you.